All right, really fast recap video of a couple topics that we've talked some about or have talked about and they looked a little bit different, but might be helpful going into tomorrow. Just in general, you'll be fine without this, but this just might be a little nice refresher. So if we had to find what point these two lines intersected at, there's a couple ways we could do this. We could build out a graph if we wanted to. We could graph both of these lines. We got y-intercept, we got slope. We could graph both of these and we could just find where they intersect. That'd be great. We figure out x, y, whatever the point is, where those intersect. The other way we could do this, that we talked briefly about on Thursday or Friday, is you could say, all right, if I want to know where these lines intersect, I'm really asking for where they're equal. Well, if I want to know where they're equal, I can just say that one line equals the other line. And from there, this is just a solving linear equations problem, where I can move my variables to the variable side, move my constants to the constant side, and divide. So then 4 would be x. At that point, you're still not done because you need the whole coordinate. So you need x comma y, so 4 comma something. Well, now we can just plug it back into either line, so into either equation, to figure out what y value would, or which y value would that line be at when the x value is 4. So in the top one, it would be 5 times 4 minus 3, which is 17. And the bottom one, it would be 7 times 4 minus 11, which is also 17, which makes sense because that's where they're intersecting. So they should be at the same point at the same time. For the second one, write an equation for a line parallel to y equals 8x minus 9. Here's y equals 8x minus 9, something like that. Y-intercept of negative 9. And then it goes up 8 over 1. Up 8 over 1. And so if we want to build a line parallel to that, we want it to run the same direction. Actually, I wouldn't even say that's quite the same direction. That's a little better. Well, so if we want them to run the same direction, they don't necessarily have to start at the same point. In fact, they should start at different points so that they're not on top of each other, but the slope should remain the same. So anything like this would be awesome because then they're both rising 8, running 1. And as a result, they're following the same path, or they're taking on the same angle or the same slope, but they're starting at different points, and as a result, they will never be in the same spot at the same time, so they will never intersect, so they are parallel. Thirdly, find the equation of the line that passes through those 2 points. We did it a few different ways at the start of the year. What we ended up finding to be the easiest as a group is we put these 2 points into a table. Now you can put them in either direction. I'll actually make it slightly more annoying for myself just because this is what I think we as a group would probably do, is we would build a table and we would put the 2 points in. You might be realizing right now why this is going to be annoying, because as we work back towards 0, because we can find the slope really easily. It's rising 1 and it's running 3. There's our slope. So if it just asks for the slope between 2 points, boom, you're done. But if it asks for the equation, now we need to find the y-intercept, aka we have to find where x is 0. So x is going to be 0 up there somewhere. So we got 12 going back to 9. So that's down 3. So we go down 3 more and get the next row. 8, 7, 6. Well, x is going down by 3. So 12, 9, 6, 3, 0. 8, 7, 6, 5, 4. And there's our y-intercept of 4, because we know that any y-intercept has to occur at a point that has an x value of 0. So here would be 0, 4. And it's 1 over 3 for rise over run. Lastly, a few angle pairs just in case the vocab comes up, because it will. We have a bunch of different kinds of angle sets, but in general, you guys are already good at solving the angles, so I wouldn't worry too much about the calculation. So for example, in this first one, if it said something like angle A is 70 degrees, what's angle B? What we would normally do in class is we would say, okay, angle A is a corresponding angle, bottom right of this intersection. So bottom right of this intersection. It's a corresponding angle to, let's call this angle C. And so if A is 70 degrees, C is 70 degrees. At that point, we'd say, okay, B and C are across from each other at this intersection, so they're vertical angles. So if C is 70 degrees, B is 70 degrees. That's how we would solve this. However, it may ask you for the following vocab. Vocab such as alternate, exterior angles. This is something that got mentioned in class, but like you weren't held accountable for it. So I want to give a little bit of a brief synopsis just as fast as I can. Alternate exterior angles, meaning they're on alternate sides of the transversal. So one's on one side of the transversal, the other's on the other side. And they're on the exterior of the two parallel lines. So they're on the outside, exterior being outside, interior being inside. They're on the exterior of the parallel lines. When you have two angles in these situations, that means that instead of saying corresponding angles, then vertical angles, you can make the jump and say that whole thing at once by saying angles A and B are alternate exterior angles, and therefore they're congruent. So then you could say, well, if A is 70 degrees, B is 70 degrees because they're alternate exterior angles. You can do the same thing over here on the right with alternate interior angles. Same kind of a mentality. They're on alternate sides of the transversal, but they are both on the interior of the parallel lines, or both on the inside of the parallel lines. Therefore, if, for example, angle A is 120 degrees, instead of having to say, okay, angle A is corresponding to this angle, let's call it C, and then angle C is vertical to B, so B is 120, you could just say, well, if angles A and B are alternate interior angles, then they're congruent. So if A is 120, B is 120. Lastly, those are alternate interior angles. And lastly, we've got same side supplementary. So if angles are on the same side of this transversal, so not alternate sides, but same side, so like here they're both on the right-hand side, and they're both interior, like these two, they're both on the inside of the parallel lines, or both exterior, so both on the outside of the lines, so here would be A and B. Those are called same side supplementary angles, or same side interior angles, or same side exterior angles. Let me try and get my pen back. Oh, I can get my pen back. So same side interior or same side exterior. But the thing to remember there is that it's same side supplementary. These two angles, A and B, these two angles are not congruent. Angle B is significantly larger, more open than angle A is, so they're not the same, they're supplementary. Meaning if angle A is 40 degrees, angle B has to be whatever angle helps 40 degrees add up to 180. Because supplementary angles add up to 180 degrees. Supplementary, 180 degrees, whereas complementary is 90 degrees. So therefore, B would be 140 degrees. Same thing in this bottom one. If B is, say, 70 degrees, these are same side supplementary because they're on the same side of the transversal, and they are both exterior angles. So therefore, A has to help 70 degrees add up to 180, so it would be 110 degrees. Hope this is helpful. Email me with any questions you have, and good luck. I will see you tomorrow.